My dear student, welcome to School of Fundamental Sciences, SOFS. I deliver some fundamental concepts of physics, chemistry and mathematics for JEE Main and JEE Advanced. It will give me great pleasure if you enjoy this concept. Up to part 7, I have discussed first limit concept, then differential calculus concept. Now, last part, integral calculus. So if we actually consider differential calculus and integral calculus, then we can solve a practical problem, otherwise impossible. Only by knowing differential calculus or only by integral calculus we cannot solve this. As well as in integral calculus we can calculate the area of a region bounded by the graph. That is very, very important. You see, I will explain. Now first, integral calculus has two distinct views. One, it is an inverse of differentiation. First I will discuss this one. Other is what? It is a special sum, not ordinary sum 5 plus 2. No, not like that. It is a special sum. Special sum means it actually can add a large number of continuously distributed small quantities, each tends to 0. That can be integrated and we can have the total sum. But if we have discrete values like 5 plus 2 plus 7, it cannot be obtained by integration. So second view is what? Integration as a special sum. First view, integration as inverse of differentiation. We will discuss first inverse of differentiation. RC 10.1. You see integration as the inverse of differentiation. Now you see definition first. Now if we have a function fx and another function gx such that ddx of gx equals to fx, then you see integration of fx dx equals to gx by definition. Yes, you see ddx of gx equals to fx. So integration of fx dx equals to gx. How to remember this? Now ddx of gx equals to fx. Now this implies what? dgx equals to fx dx. Like this, like dgx equals to fx dx. If we integrate both sides, what will happen? Integration of fx dx equals to integration of dgx. You see our standard result, integration of dgx equals to gx. So it is a definition. Definition is what? So if we have the two functions, continuous functions obviously, gx and fx, such that ddx of gx equals to fx, then in inverse of differentiation means what? Integration of fx dx equals to gx. That is the inverse of differentiation. Now in this situation we need an idea of constant of integration. How? Let us see. Now already we have explained ddx of gx equal to fx. Also we can write in this way also ddx of gx plus c is a constant, equals to what? ddx of gx, because ddx of c is 0, is equal to fx. So then also we can write integration of fx dx equal to what? gx plus c, general value. Yes, you see ddx of gx plus c is equal to fx. So if we have integration of fx dx equals to gx, general value will be what? Integration of fx dx equals to what? gx plus c. How? Again you can realize d dx of gx plus c is equal to fx. So d of gx plus c is equal to what? fx dx. So if we integrate, fx dx equals to what? Integration of d gx plus c. d gx plus c is equal to what? gx plus c. In the result also I will show you integration of dx equals to x. Integration of dm is equal to m. Integration of dfx is equal to fx. Alright, so here also you see integration of d gx plus c. Integration of d gx plus c is equal to gx plus c. And this c is called constant of integration. Now RC 10.2, integration, second view, integration as a special sum. There are two concepts. One is analytical concept, other is graphical concept. Now you see the analytical concept first. Now already I have explained. You see integration is a process of evaluating the sum of large number of terms of the type this y dx, that is fx dx. If you choose y is equal to fx, so y dx equals to fx dx. Obviously dx tends to 0 means what? Fx dx also tends to 0. That's why it tends to 0. and x will continuously varying from a to b. This sum can be denoted by integration fx dx, lower limit x equals to a to upper limit x equals to b, and that is called definite integral of fx with respect to x within the limits x equals to a to x equals to b. Now next, if we have a continuous function gx such that same as before ddx of gx equals to fx, then clearly integration of fx dx from x equals to a to x equals to b equals to what? Gx. Upper limit x equals to b, lower limit x equals to a. Then from Newton-Leibniz theorem we can write g of b. Let us see. If fx dx equals to gx plus c is equal to psi x a, then fx dx x equal to a to x equal to b is equal to what? Psi x equals to a to x equals to b. So Newton-Leibniz theorem, psi b minus psi a. Now what is psi b? gb plus c. What is psi a? ga plus c. C cancel out. So we will have gb minus ga. Thus, in definite integration, c does not appear. Now graphical concept, you see, suppose it is the graph for y is equal to fx. Now at a distance x, yes, we can, it is a y, we can have a vertical line parallel to y axis, it is a y, and for the length dx, so it will be what? Y plus dy, because this is the what? X plus dx, so it will be y plus dy. Now since dx is very very small, this curve part can be considered to be a straight line. So this deep shaded region, yes, looks like a trapezium. What will be its area? The area of the rectangle y into dx plus area of the triangle. But since the area of the triangle is much smaller than the area of the rectangle, so it is sufficiently close to area of the rectangle. So this area of the deep shaded region, we can say y dx. If you apply the formula for area of the trapezium, then also we can have same answer. Then obviously you must cancel the term like that, dx into dy like that. Dx dy, there you see dx into dy is connected with the yes y dx by plus sign or minus sign. So there also we can neglect dx into dy, yes, like dx whole square, dy whole square like that. So area of the deep shaded region, you can choose what? Y into dx. Again I am telling you, you see it is the area of the trapezium is equal to what? Area of the rectangle y into dx, area of the rectangle plus triangle. But since dx tends to 0, the area of the triangle obviously very very sufficiently close to 0, because this line will move towards left. So making the what? Area of the triangle tends to 0. So actually the area of the deep shaded region is sufficiently close to area of the rectangle of length y and width dx, that is y dx. Already in the figure, yes, you see, yes, you see this. So clearly what is the total area of the shaded region? So clearly what is the area of the deep shaded region? Already you have obtained fx dx. Now we have to add this area from x equals to a to x equals to b. That is denoted by integration of fx dx, x equals to a to x equals to b. So we will have the what? Total area of the shaded region. So that is equals to total area of the shaded region equals to integration of x equals to a to x equals to b fx dx.